how do we know how old a fossil is? In this video, we'll explain the different methods by which we date fossils. Let's start with a brief explanation by Dr. Rick Potts, Director of the Human Origins Program at the Smithsonian.
Well, there are about 12 to 14 different methods of geological dating that use the principles of physics and chemistry and the refined measurements of changes in chemical isotopes and ratios. These are refined techniques almost year by year in getting more and more precise dates. And so those 12 or 14 different methods can be compared with one another, and generally it's very, very hard to get a paper published about the new fossil or the age of that fossil without also comparing a whole variety of different techniques to really solidify using different aspects of physics and chemistry to confirm the age and test the age of a particular fossil.
Clearly, there are a lot of ways to establish a fossil's date. We'd like to go more in depth on just a few. The first is radiometric dating using isotopes, as Dr. Potts mentioned. You may have heard of carbon-14 dating. This is a type of radiometric dating, but as we will learn in a moment, it decays too fast to be used on the fossils we are interested in, but we will use it to explain the process. Isotopes are atoms that contain different numbers of neutrons. You may remember from high school chemistry that the nucleus of an atom contains both positively charged protons and neutrons with no charge that make up the bulk of the mass of an atom. Using carbon as an example, most carbon is carbon-12, meaning that it has 6 protons and 6 neutrons, which adds to a mass of 12. But some carbon in the atmosphere, a very, very small amount, 1 out of every 10 trillion molecules of carbon on Earth, has 2 extra neutrons and is called carbon-14. Carbon-14 is unstable and gradually decays by one of its neutrons splitting into a negatively charged electron and a positively charged proton. The electron is spat out and the new atom is nitrogen-14. When an organism is alive and breathing in and out, exchanging carbon with the environment, its carbon-14 to carbon-12 ratio will match the environment. But once it dies, its carbon-14 amounts will slowly but surely disappear. For carbon-14, it will lose half the amount it had when it was alive every 5,730 years. This means that for fossils that are several 100,000 years old, like the hominid fossils we are studying, carbon-14 amounts will be undetectable. Dr. John Hawks, paleoanthropologist from the University of Wisconsin-Madison, explains how we can date these much older fossils.
The most important methods that we use are uranium isotope dating, because flowstones in caves that are forming by dripping water have uranium in them, and the uranium fraction of it decays into other products, thorium, ultimately lead. And we can measure the ratio of those to get an estimate of when
and it's the stone you're looking
deposited.
at, a stone around
Exactly.
the flowstones.
Exactly. Yeah.
So we use another radioactive isotope, uranium-238, that decays into lead by expelling several different particles. John goes on to explain,
like sometimes you get rocks. This is a bit of flowstone here, right? You see the layering, right? Sometimes you get rocks where, oh yeah, it's there. And sometimes that rock is actually right on the fossil. If that happened, then you could say, well, that rock formed after the fossil was there. Usually that doesn't happen. Usually we're looking at a big fossil deposit and we're finding that there are flowstones that formed on top of it, maybe flowstones that were there before the fossils were there, right underneath of it. And that gives us a bracket, right? We have a minimum age, we have a maximum age. There's other things we can do with sediments. There's things that we can do with the fossils themselves in some cases. We use in caves like this nowadays 4 or 5 different kinds of dating.
And why do you do that?
Dating results have different strengths and weaknesses. They're none of them directly associated with when the thing lived. Right? Carbon-14 kind of gives us that, but carbon-14 only goes back to about 50,000 years ago. So then we're relying on geological processes.
As Dr. Hawks explains, we have to use the dating of rocks, geological dating as he called it, because dating the actual fossils is really difficult. But how is that done? As Dr. Hawks explained, we try to date the sediments around the fossils, particularly flowstones that are formed by dripping water. Dr. Lee Berger, paleoanthropologist at the University of Witwatersrand in South Africa, gives us a glimpse at a flowstone in an actual cave at a site near the Rising Star Cave system.
Here's a perfect flowstone right here. You'll rarely see a more beautiful one. It runs right along here. And it's where the water creeps over and releases calcium carbonate onto the surface, and that builds up over time. And at the same time, we can date these flowstones because they radiometrically reset a clock using uranium, lead, and uranium helium. And in this case, you can see it gives us a perfect base to that. All of this material formed on top of that. Here you see a stalagmite that comes in this area. There's stalactites in here. And then we have other flowstones that form into the interior of that. And those allow us to give bounding dates, oldest and youngest, on a deposit like this.
So you can see how dating the rocks both above and below a fossil deposit can give us a range of dates within which the fossil must lie.